Greetings. So today we're going to be talking about regular polygons finding their area. Remember, you got this. I believe in you. Okay. When you had your assignment yesterday, you talked about all the generic quadrilaterals. You had the circles. I had these images. Hopefully you use this to fill out your vocabulary tracker to have that up to date. Today we're talking about, shapes more than four, because let's face it, they exist. However, we've also kind of established that everything really does boil down to that magical little triangle. So, I'm gonna start there. So, for your title, for your notes, go ahead and just give this the whole, area of regular polygons. Okay, and start off, draw yourself just a nice simple triangle. Specifically equilateral. Now, doesn't matter what the triangle is. I know that the area is 1/2 of the base times the height. Let's make sure that looks like an H. Right? The height, as you know, is an altitude of a triangle. Altitude, altitude, altitude. So this is my base, which is my height. I'm going to put in altitude in here. That's your normal thing. Now, regular polygons, remember, it's really just a bunch of congruent triangles on the inside. Right? So if I have this hexagon here, and I'm like, wait a minute. I'm going to have just 6 triangles, right? If I had a pentagon that was regular, I would have 5 isosceles triangles as well. They're all just going to be a whole bunch of the same triangles, which means if I have any regular polygon and I can just figure out what is one of these triangles, right? And actually, for the purpose of this, I'm going to temporarily make that 8 disappear. Make that 8 disappear for me. I don't want that there. I'm just going to start off with the fact that I have this hexagon, and I actually don't want that there either yet for the purpose of this. Actually, that's good there. If I were to just cut this into 6 congruent triangles, right? And I just want to take this general knowledge, the same thing, and I just kind of want to apply it to this knowledge, right? So in this particular case, I have like 6 triangles, right? If I have a pentagon, I would have 5 triangles. If I have an octagon, I have 8 triangles. So in other words, that when I'm solving for the area of this thing, I'm going to have the area of a triangle times however many number of sides there are. 6 triangles come from 6 sides. 8 triangles come from 8 sides, and so on. Now, this is just pure definition for you to have. I'm still going to refer to the base of one of my triangles as my little b base. Right? I know that an altitude, starting with that letter, instead of thinking about it as an H for this purpose, I'm thinking of it as an altitude, but there's actually a word which is apothem. All an altitude really is, an apothem is the altitude. They both start with A. That makes it a little bit easier. So if I was just focusing on this one triangle here, I know that the area of a triangle is normally 1/2 base times height. But that means my area is 1/2 of the base times the apothem times the number of sides. Right? Because 1/2 base times the apothem is going to get me this one triangle inside, and then I'm going to multiply by the number of sides. That's going to give me the area of any regular polygon, right? So the work that you're going to be doing tomorrow is going to be giving you something like this, right? So I have, let me get this in the same area. And again, please don't jump ahead on assignments because I want you to have something to do with your class. So if I have this and I gave you one that's just nice and simple, and it's just, so area is 1/2 of the base. I just realized that this didn't give you the apothem. That's not going to work. This needs to be in the center. Let me fix that. I meant for that to be the apothem. So if that's 4, I have 1/2 B A N, right? This is a base. Now, the reason it's a base is it's a regular polygon, which means it's also 5.88 on all of the sides. Those are my little b bases, which is just each side is considered a base, because if I knock it over again and again and again, who knows which one's on the bottom? They're all the same. In this particular case, 4 is my apothem, and the number of sides at the pentagon is just 5. So I'm just going to simply plug this in to my calculator, where I'm going to have a 1/2 times my 5.88. Actually, that was supposed to be the 4 first. Let me line it up just so that it lines up with the formula in case people are confused on where they came from. So my base, actually I did that right, 5.88 is my apothem. My base look at me doing it like 3 times over. Apothem is 4, number of sides is 5, right? So number of sides, right, because this is a pentagon, .88 is my base. Four is my apothem. And I'm just going to let my calculator do the work for me. So I'd have a 1/2 times 5.88 times that. If I did everything right, I should end up, look at me typing things into my calculator wrong. So 0.5 times 5.88 times 4 times 5, I should end up with 58.8. And if you're given units, for instance, this could be like centimeters squared, something like that. Okay, this is how I'm going to do it. If I have a regular polygon, it gives me the base, it gives me the apothem, I can count up the number of sides, I stick it into the formula, but that's kind of why it works. It all comes from triangles. Now, revisiting this one over here, because on the back of the assignment, you're going to end up having somewhere it's just going to be asking you to do it with trig. But let me pause, or suggest you pause it long enough to finish getting these notes. So if you have to pause, please do. Okay. Now that we have the basics, this is what you're using tomorrow. Also going to show you some trig stuff you're going to use tomorrow. Now, specifically for tomorrow's, I'm going to focus on just the special right triangles because those are faster, they're easier, and we will deal with right triangle trig and SOHCAHTOA stuff the next day. So, I'm going to point out that if I had a hexagon specifically, right, because I know that 360 divided by 6, I know all of these are 60, I know those are all isosceles, which means every single one of these things would break down to just be another right triangle. Sorry, equilateral triangle. So if I have 6 equilateral triangles, but if I just think back to when we first did stuff, right? When we first talked about triangles here, I knew that if I chopped one of them down the middle, if you remember that derivation day, right? That's going to kind of go away. Here's my 30, 60, 90 triangle now. I have my x, I have my 2x, and I have my x square roots of 3. Every single time I have a right triangle. Now, that means in a hexagon, because I can split these all up into equilateral triangles, I have a whole lot of x, 2x, and x square roots of 3 going on. So this is where I'm going to actually have the one with the problem that's here. If I just treat this as like, oh, wait a minute. I knew that I had this right triangle. If I drop this apothem straight down, so I now have an equilateral triangle, and I'm going to chop into 2 right triangles. So I'm going to focus on this now, get rid of that one. So I'm only focusing on this guy. And that's my pattern. So I'm like, wait a minute, if I have a 30, 60, 90, that means that's going to be 4. And that's going to be 4 square roots of 3. Because it's a 30, 60, 90. And now with that knowledge, wait a minute, I just solved for my apothem. I know that this base is going to be double that. That's going to be my 8 again. So I know my base is 8. I know my number of sides is 6. And all of a sudden, I have enough information to solve the problem, even though I only started with one piece. Right? Same thing. Even if I just gave you, here's my generic equilateral triangle, and I just said, hey, can you just solve for the area of this triangle if I know it's equilateral, and I just said, hey, this is 12. Well, I know if I drop this down the center, that's 6. Means this is 6 root 3. I know a triangle is 1/2 base times height. So if I have a half of 12 times 6 root 3, right, that's 6 times 6. I have 36 root 3, and I'm set. This is just times the number of sides. That's it. You're going to be using this trick. Now, let's say that I had a square, and it gave you the radius, meaning the distance from the center to the edge, and it just said that this is 10. A few different ways you can do this. Now, first, I still got this trig thing working out. If I chop this down here, that's also 10. Ooh. And I know because it's a type of rhombus, I know that those are perpendicular, which means I have a 45, 45, 90, which means this is just 10 root 2. And because it's a square, using those quadrilateral formulas, I know my area is just going to be 10 square roots of 2 squared, which is 100 times 2, and I get my 200 square units. Now, this is not the only way to do it, but it is a way that you can do it with the right triangle trig that they're going to be expecting you to show. I'm also going to give you a reminder that if this is a rhombus, and all of those are radii, which means they're all a part of the diagonals, you've got something else that you can do with this, and I'm going to encourage you to discuss with your classmates what is another way that you could find this exact same area without necessarily using the trig. Trig works, trig is perfect, but if I'm just saying that this radius, I'll pick a different number, let's just say that this is 12. And I want you to try to find the area of a triangle using that radius with trig, without trig, either. But finish that up for your notes. Bring this in. Make sure you're ready to show Mr. Rubenfeld tomorrow. And I hope everything goes great. Talk to you later.